The vacuum of space. Step outside the International Space Station without a suit, and you have about 15 seconds of useful consciousness. Not minutes, seconds. The moisture on your tongue begins to boil. Your lungs collapse if you exhale too slowly. The pressure differential tears at soft tissue almost immediately. What most people picture is an explosion. What actually happens is quieter and far worse. Your blood does not boil because your circulatory system holds pressure longer than the rest of you. You stay technically alive for a window that feels like mercy, but is not. NASA engineers call this the unsurvivable but survivable adjacent zone. The real terror is that the vacuum does not announce itself. No sound, no wind, just a door, a seal, and then nothing holding you together. The scale of the observable universe. Lay out every grain of sand on every beach on Earth, and you still have not reached the number of stars in the observable universe. The current estimate sits around 2 trillion galaxies. 2 trillion, each one containing hundreds of billions of stars. The observable universe stretches roughly 93 billion light-years across. That word, observable, is doing enormous work. It means the part light has had time to reach us from since the Big Bang. The actual universe is almost certainly larger. By how much? Physicists cannot agree. Some models suggest it could be infinite. An infinite universe means every possible arrangement of matter repeats. Somewhere, that arrangement includes you. That detail tends to stop people cold. Rogue planets. There are planets out there with no star, no sun, no orbit. They drift through interstellar space alone, ejected from their home systems by gravitational chaos, and they vastly outnumber the planets we consider normal. Estimates suggest there could be billions of rogue planets in the Milky Way alone. Some are gas giants the size of Jupiter, wandering in permanent darkness. Here is the pivot. A handful of these rogues may still host liquid water. Radioactive decay in their cores generates internal heat. A thick hydrogen atmosphere could trap that warmth. So somewhere in the dark between stars there may be worlds with oceans and no sun. What lives there, if anything, is a question science has not yet had the nerve to fully ask. The Great Attractor. In 1973, astronomers noticed something was wrong with the map. Galaxies across a massive region of space were moving toward a single point, not drifting, accelerating. The Milky Way is part of this movement. We are being pulled towards something with the gravitational mass of tens of thousands of galaxies. The problem is we cannot see it. It sits behind the zone of avoidance, a region obscured by our own galaxy's dust and stars. What we can verify is the pull is real. The object, called the Great Attractor, sits roughly 250 million light-years away. We will never reach it. The universe is expanding faster than we are falling, but the fact that something that massive exists and we still cannot fully observe it rewrites the definition of unknown. Magnetars. Take a star roughly 20 times the mass of the Sun, collapse it, compress it down to a sphere about 12 miles across. Now give it a magnetic field 1 trillion times stronger than Earth's. That is a magnetar. On December 27, 2004, a magnetar called SGR 1806-20 released a burst of energy in about 1/10 of a second. That burst was more energy than our Sun emits in 250,000 years. It hit Earth from 50,000 light-years away and still measurably compressed our ionosphere. If that event had originated from within 10 light-years of Earth, the atmosphere would have been stripped. The oceans would have followed. Magnetars do not warn you. They do not build up. They simply release, and everything in range pays the price. The Fermi Paradox. In 1950, physicist Enrico Fermi sat down to lunch and asked a question that has never been answered. Where is everybody? The universe is 13.8 billion years old. It contains trillions of stars. Many have Earth-like planets. Even at sublight speeds, a civilization could colonize the entire galaxy in a few million years. That is a blink in cosmic time. So why is there no signal, no artifact, no evidence of anyone else? Scientists call this the Fermi Paradox. The explanations are all unsettling. Either intelligent life is extraordinarily rare, or something keeps wiping it out before it spreads, or civilizations reach a point where they go quiet for reasons we cannot yet understand. Every answer implies something about our own future. None of the answers are reassuring. Gamma-ray bursts. The brightest explosions in the known universe last between a few milliseconds and a few minutes. Gamma-ray bursts release more energy in that window than the Sun will produce across its entire 10 billion-year life. They are believed to originate from collapsing massive stars or merging neutron stars. The beam they fire is narrow and directional. If one is aimed at you, there is no warning. Gamma rays travel at the speed of light. The signal and the destruction arrive together. Some researchers have proposed that a gamma-ray burst within our galaxy, pointed at Earth, could trigger a mass extinction by destroying the ozone layer in hours. There is evidence this may have happened before. The Ordovician extinction, roughly 445 million years ago, fits the profile. The sky itself has a kill radius. Time dilation. Einstein proved that time is not a constant. It bends. Near a massive object or at high velocity, time slows down relative to an outside observer. This is not theoretical anymore. GPS satellites have to correct for it daily, or navigation systems drift by miles. Astronauts aboard the ISS age slightly slower than people on the ground. But the extreme version is what should concern you. Near a black hole's event horizon, time slows so drastically that a person falling in might experience hours while thousands of years pass outside. You would not feel the difference. You would not know. You would simply look back and find that everyone you knew had been dead for centuries. Time dilation does not feel like anything. That is the part that is hard to absorb. Black hole information paradox. When something falls into a black hole, it is gone. Or is it? Stephen Hawking showed in 1974 that black holes slowly evaporate by emitting radiation. Eventually, they vanish completely. But here is the problem. Quantum mechanics insists that information cannot be destroyed. So where does the information about everything that fell in go? Hawking spent decades on this. He changed his position at least once. The physics community has not resolved it. Some argue the information is encoded in Hawking radiation in a form we cannot yet read. Others argue it is stored on the surface of the event horizon. The terrifying implication underneath all of this is that if information can be destroyed, the entire framework of physics breaks. The universe operates on rules that may not fully survive contact with a black hole. The heat death of the universe. Every star will eventually burn out. The last red dwarf will cool in roughly 100 trillion years. After that, the universe enters a phase called the heat death. All usable energy is gone. No temperature gradients exist, which means no work can be done. No motion, no chemistry, no thought. The universe does not explode. It does not collapse. It simply reaches equilibrium and stops forever. What makes this genuinely hard to sit with is the timescale. 100 trillion years feels abstract until you map it against the fact that complex life has existed on Earth for roughly 600 million years. We are extraordinarily early. The long darkness ahead makes everything that has ever happened, every civilization, every star, every moment, a brief, improbable flicker. The observable universe's edge. Right now, galaxies at the edge of the observable universe are receding from us faster than the speed of light. Not moving through space faster than light. Space itself is expanding faster. This means light from those galaxies will never reach us. They are already beyond any possible contact. We are sealed inside a cosmic horizon, and here is the detail that changes the frame completely. That horizon is shrinking. As the expansion of the universe accelerates, more galaxies cross the threshold every billion years. Future civilizations, if they exist, will observe a smaller and smaller universe. Eventually, they may look out and see only their own galaxy, surrounded by darkness, with no evidence that anything else ever existed. They may conclude they are alone, and based on their evidence, they would not be wrong. The pale blue dot. On February 14, 1990, NASA commanded Voyager 1 to turn its camera around from a distance of 3.7 billion miles. The resulting image shows Earth as a fraction of a single pixel, a mote of dust, suspended in a sunbeam, as Carl Sagan put it. Every war, every empire, every person who ever lived, contained in a dot too small to fully resolve. The camera was turned off shortly after to save power. That image was never meant to be scientific. It was meant to be a mirror. What it showed was that from the perspective of the cosmos, Earth has no protected status, no guaranteed future, and no audience. Whatever happens here happens in silence. At a scale the universe does not register. Space is not a backdrop. It is an active, indifferent system running processes that dwarf anything humans have ever built or imagined. The facts do not require exaggeration. The vacuum kills in seconds. The scale defeats language. The darkness is not empty, and the universe will outlast every question we have ever thought to ask about it. The most unsettling part is not any single fact. It is the certainty that the list does not end here.